30-minute timer. Okay, let's...
Okay, 30 minutes and counting.
Gotcha. So we're going to practice talking while we code. Today we're going to do the memoized Fibonacci. Okay. So the Fibonacci sequence is traditionally used to explain tree recursion. Yes, 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 this algorithm serves well, but it's not efficient. Not just because of the recursion, but because we invoke Fibonacci twice in the right branch, da 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 da. Yeah, this is obvious because as this grows, we're doing n minus 1, n minus 2. So for n10, then we have to do 9, which means we have to do 8 and all the way down. And then on the right side, we're doing minus 2, which means we have to do 8 and 7 and all the way down again. So it's saying blah, blah, blah. Implement the memoization solution. So this is basically just telling us what to do. It's saying keep track of the memoized results. You need to have a cache, most likely an associative array. Refactor this so that it's memoized. Okay, this might be super simple. Maybe I'll screw it up. There we go. Make sure that we're talking to the background here. Okay, so memoization basically means we need a cache of all the different values that we already hit. If we were being really clean, we would put the cache inside here, inside of this function, but for simplicity, my code timed out. For simplicity, we're going to put it up here. And every time we return every time we calculate a value, we're going to add it to the cache. And it's going to be keyed off of the number that we are I guess we don't need to do it. It's going to be keyed off of the number that we're returning. We don't need to do it there. That's pretty silly. So here we're going to calculate the value. We're going to store it in our cache. And so that's sort of the first step. We need to keep track of what we've done. Now, in addition to that, we can check here. We need to check the cache and see if it's already there. If it is, bail out. So if cache in So here we're saying, hey, I'm looking for Fibonacci of n. I'm going to say, let's check the cache. If it exists, then go ahead and return that and skip all this recursion. Otherwise, if it's one of these two, go ahead and just return the number. Finally, if it's not one of those, then we need to go through and calculate it as we calculate the stuff. We need to store it in the cache and then return the value. So let's send this, and that works much better. If we do attempt, all great. Wow, that was not 30 minutes at all. Okay. So is there... And that's it. There's nothing more to say about this one. I suppose we could make it a little nicer by giving it, sort of wrapping up this cache and putting it inside, or maybe instead of having this cache out here that's outside of the value, it's sort of a bad sign that this Fibonacci method is referring to stuff that's outside of its scope. So what if we put the cache in here? There you go. We'll include the cache here, the default value. And so that means every time we call it, we have to include the cache. I don't know if this is going to work. If we do it this way, we need to this is fine. We're providing the cache as a reference. So inside of the function, we're going to look at the cache and see, hey, is there something in here we can use? I guess we are updating it. I wonder if we're just returning the value. I guess the way this works is I'm honestly not sure how it's going to work. So the first time it goes through, there will be no cache. Obviously, we'll start creating the cache. Let's just try it. Oopsie. Yeah, so like sort of from the outside. So when we say Fibonacci 10, there is no cache. And we're at 10 right now. So we are going to call it again with this cache, which is empty. As it goes in here, it's going to go all the way down. It's going to be empty all the way down to 1, right? It seems weird. I don't understand how it's getting filled. So let's do some debugging so we can walk through it. So we'll do Fibonacci of 6. And we are going to say node inspect Burke. This is called memfib. So it's going to open up the debugger for us, I think. It's going to pause right here. And now let's kind of walk through this. So there we go. So our current value, and our cache is empty. I'm going to watch these. I want to watch, not the queue. I want to watch the cache. So it's empty here, so we're going to go into it. Now our cache is still empty. We're going to run down to here. It's going to go down again, and again, and again. Ah, crap, I ran all the way past it. Okay, let's try again. Again. So now we're at 4. I'm going to call it 3. So this should be here, stopping it. So at this point is n. There we go. Okay, so we got all the way to n equals 0. Notice our stack is pretty huge, right? From here, we're calling recursively. So at this point, our cache is still empty. But finally, we're going to be able to step out of here, and we have our first value. Now, I guess we're going to be stepping, well, that would have been this one here. So now we're going to step into this one, right? And the cache is still empty because we need to calculate 1 -1 and -2 before we get a value for the cache. Some poopy. Go ahead and go through to here. Here we are. N equals 0. Finally return it, and we finally have a value for N2. And we get to set that in our cache. And it is by reference. Oh goodness, this is so dirty. So the cache will work, it looks like, because, step out of here. At this point now, we do have something in our cache. Yeah, this is so dirty because we're passing the cache in and we're updating it by reference. So it is kind of working, although this one has to go all the way down. Sorry. This one has to go all the way down. And then this one has to go all the way down. Then we get a cache. So like we've already missed optimization there, and then it's just, like I said, dirty stuff. So I don't think that there's a lot of benefit to doing it that way. So let's just go ahead and, if we could return a tuple that like had the cache and the value, that would maybe be better. But oops. Code. So, I suppose we could also just wrap this, right? So, if we return the function in here and we kept the cache, right, so this would be that should work, and it hides the cache, which is nice. The way that works is we're using an immediately invoked function expression that will return our function, but it's sort of that revealing module pattern, like we've got the cache in here, so it's separated from everything else. So I think that's nice. Let's see, can or should we refactor any of this stuff? I think it's good enough. Whoops. Attempt. Let's say submit. And that's that. How much time do we have left? Should we do another? We got like 16 minutes left. Let's do another one. What the hell? So this one's going to be the first non-repeating character. Just call it this. So in this one, we're going to write a function called law that takes a string input and returns the first character that is not repeated anywhere in the string. For example, we'll get the input stress. The function should return t, since t is the only one that occurs once. As an added challenge, upper and lowercase letters are considered the same, but the function should return the correct case for the initial letter. Got it. So the logic's the same, but return the same case there. If the strings contain all returning characters, it should return an empty string, or none. Okay, this seems cool. So let's just talk through this real quick. We need to iterate through the string, and we need to figure out how many times we need to tally up how many times each string occurs. So in order to get the tally, we're going to have to walk through at least once. So can we minimize this and sort of do it as we go? In their example, stress, one letter at a time, we're not going to know what they are. So I think what we need to do is to build out a tally, and the tally would be, a map with each one of these and how many times they're found. So let's split this into two different things. We could build out the counts by just walking through and incrementing as we find things. Then the next part of the equation, or the next challenge, is to figure out which one, if any, occurs only once. And the third part is to return that in the same case that it occurred in the same case for the initial letter. So let's just kind of throw out some notes here. So we're going to have to tally the characters. And return so tally is going to be a map, and we can walk through each of these. We could split it and then walk, but we'll do a more traditional loop and just grab things by their index from the string. And just to keep this very explicit, we'll add a little variable there. And I just want to see that we are passing this. Okay, we are getting each letter, all fine. So how are we going to tally this up? We need to normalize the casing of each of these. So to do that, we'll just do to lowercase, and then we're going to say the tally. Whoops. We say that we just need to increment this, and we'll say that the tally letter equals, is that already there, or 0 is 1. So let's look and make sure that we're getting tally. We have an A, ST, STR, yes. Okay, cool. So we're able to tally these correctly, which is what we got here. Now we need to figure out which one of these has not been repeated. So it is wasteful for us to go through and tally everything when we might find a unique letter right up front. But for simplicity's sake, let's walk through this thing again, and we're going to say, because we need to get these in order, right? So let's walk through this again, and we're going to say if the tally is 1, then this is our letter. So if we only found 1 in here, then this is the letter we need to return. But as we mentioned, we're going to return it in the proper case. Oh. Now, if we get all the way to the end and we don't find anything, then it said that we should also return empty string. So that works. And I assume with these bigger data, well, no, that works too. I was assuming that with bigger data sets, this would be pretty lame. So, I mean, it is working, but how could we optimize this? We're walking through and tallying everything when we might not need to. Plus, we're logging a whole bunch. So, what if, while we're going through, let's say, we can check its uniqueness right here. So screw the whole tally idea. We could just say, as we're walking through, we'll say, is this unique? So a way to check the uniqueness, I guess, would be for us to check for another index that's after this one. So we'll say unique equals index of wait, if we do index of, that will not be, that will be case sensitive. What if we use regex? That might be a fun way to do it. So, what if we do, a test to say like, well, we need to do near regex of this letter in global, case insensitive. So what if we tried, we made some regex for it, and we would determine its uniqueness by whether or not we have multiple matches here, the length of the matches. So let's do s.match, what is it? I always forget if it's s.match. Match. I have to do exact to get all of the groups, right? One second, need to figure out how to use regex. There we go, match. Okay, so unique. So that would be the S, which is the string, match our regex. So we need to figure out if it matches and if the length is more than one. So matches equals here. And finally, we can say unique if there are matches and the matches is greater than 1. So if it is unique, let's just log some stuff. I haven't executed anything in a while, so I'm getting nervous. So let's say we're going to log S, the letter, and unique. Survey says, is it unique? I don't know. Ooh, I'm assuming that there's at least one. That's bad logic. But anyway, says, is this unique? No, I got this backwards. It's not, or well, let's say it's repeated, if this is true. So, is this repeated? No. Is this? Yes. No. Okay, this is a lot more direct. I mean, regex is going to be quite optimized, but probably faster than looping through stuff over and over. Oops. So, we can now say if it is not repeated, return the letter in its original case. This might be a little bit nicer. So that silly tally. So let's try this code. That works. Let's try them all. That works too. I think this is a lot easier to understand. And we're only looping through once, and then we're letting the magic of regex do a lot of the hard work. Since that's a lot lower level, internally it might be doing a sort of a more of an expensive operation because it has to look through everything. But I'm willing to bet that it's a lot faster than us looping through. So anyway, I'm going to say that's good. Whoops. So we're going to solve a couple more. I don't remember what we did. Oh yeah, solve mem, fib, and repeating the card. All right, that's it. That's all I'm doing for today. Goodbye.